Hi all, my name's Giuseppe. I'm a senior Flutter developer at Phantom, and today I want to talk to you about how to make your life easier on the CLI with some automation. So I want to start my talk with 3 questions. First of all, who has already heard about Sidekick? Okay, I would say like 10 or 20% maybe. And who's actually using a Sidekick CLI? Oh, okay. All right, that's perfect, because I hope I can teach you some things then. My last question is, how do you usually organize repetitive tasks in your work as a Flutter developer? So working in all the projects I did, I saw following approaches. You could have a README, which is always great to have for documenting how things work. And here you could, for example, document, okay, execute this and that command to deploy the app, for example. However, this may become outdated and it's not debuggable or testable. Another way to organize repetitive tasks is through bash scripts. Now you can reuse them, that's great, but who here likes writing bash scripts or debugging them? There's just so much magic involved. Another way is aliases. Those are great to make big commands easier to run. For example, with the dreaded flutter pub run build runner gen whatever command. However, you can test or debug those either, and they're not scoped to your project. You can also define run configurations. This is great to make running your app easier if you have to pass in a lot of environment variables and stuff. And another thing is to just make the CI do tasks for you. For example, for deploying, instead of doing it locally through your CLI, you could define a GitHub action, which you can also start manually. But alias, this isn't debuggable as well, and you probably have to write it in bash as well. So wouldn't it be nice if we could take all the positive aspects of these approaches and get rid of the negative ones? So I believe that every project needs a CLI, just like every superhero has its own sidekick, like Batman and Robin. And I'll show you how to generate your own CLI as a sidekick for your Flutter project, to combine the positive things of the previous approaches and get rid of the negative ones. So let me get my laser pointer. No. Okay, so this is a way your CLI could look like. You would have one CLI for each project, and it would be custom and scoped just with the commands you need in every project. It also has the documentation already inside of the commands, like help parameter you can use to get more info on your commands. And it's scoped and testable, debuggable. It just has the best things of all the approaches combined. And you write the commands in Dart, so it's a language you already know and are familiar with, so you don't have to deal with that much bash anymore. So for example, one CLI could have a deploy command, and then in another project you could have another CLI which has a command to start integration tests on Firebase Test Lab. Okay, now let's get you all your own CLI for your projects. You can use the topic parameter on pub to search for tagged packages. This makes it very easy to find all the Sidekick related packages. And you will find a lot of packages here. The only important one for us right now is this package here. It's the generator CLI we will use to generate our own Sidekick CLI. So install the generator CLI with .pub global activate Sidekick, and then run Sidekick in it to start generating your own CLI. So the generation process is pretty straightforward. You'll be asked 3 questions. The first is, where should the entry point of your CLI be placed in? So the CLI executable, I'll just go with the default option, which is the root folder here. Then the hardest question of all times, naming things. You have to give your CLI a name, and I know we developers always struggle with naming variables and stuff. So I'm just gonna go with a short name. I'll name my CLI SD for Sidekick demo. And the last question, so your CLI is going to be a Dart package, and you have to place it somewhere in your repository. In a monorepo, you could place it in the packages subdirectory. I'll just place it here in the root directory. Okay, that's it. The CLI is now being generated. And one thing you can see here, it's saying something about using cached Dart SDK, and that's actually a pretty powerful feature of Sidekick CLIs, because they use their own Dart runtime, so they download own fixed or pinned version of the Dart SDK, and this is great because it makes it super stable, so it doesn't depend on which Dart SDK you have installed on your system, but it runs always as expected and stable everywhere. Great. Now we can run our CLI, so just type in /sd, and then you'll see this compile message. This is also an important concept for Sidekick CLIs. So every time you have changes in your CLI, it will recompile. Because as I've told you already, it's a Dart CLI. So you write the CLI code in Dart. However, you don't want to run the CLI in interpreted mode, because that would be very slow. So what Sidekick does is that it compiles a binary out of your CLI Dart code. This is great because it makes running the commands much, much faster. And so the first time that you generate your CLI, it hasn't been compiled yet, so your CLI will just get compiled in this beginning. Then the next command I run is /sd sidekick install global. And here's an important distinction. This causes lots of confusion. So SD is our own CLI we just generated, not Sidekick. The Sidekick CLI we used here, that's just a generator CLI. We won't use that anymore. And now I'm running the command sidekick install global. So every CLI comes with a sidekick command, which then has subcommands. In this case, I'm calling the install global subcommand. And what this does, it just adds the SD entry point file to path, so I don't have to type the / every time I want to use my CLI. Okay, now let's call our CLI for the first time, and you'll see a help screen. Here you can see all the default commands that are generated with the default CLI. They're all pretty basic, except for the deps command. That one's actually kind of cool because it gets the dependencies of all packages, which is handy if you're in a monorepository. So you don't have to cd into every directory and then run .pubget. It does this for all packages in the repository. Okay, now let's look at what was actually generated. So what's the structure of the CLI we just generated? It's pretty easy. So here, SD, this is the executable CLI file for the, it's the entry point. It's a magic bash script which takes care of recompiling your CLI when needed, downloading the Dart SDK, and running your compiled Dart code. And SD underscore sidekick is the Dart CLI package you will use to customize your own CLI. And you will basically do this just here in the lib folder. There's the commands folder. You can add your own custom commands here and register them in the SD underscore sidekick.dart file. And then there's this tool directory, which is just some magic bash scripts. Don't worry about those. So in the next step, we will add our custom commands here because yeah, we want to have our own custom CLI with our own custom commands that is just perfectly adapted to the project we are in. Let's start by adding our first custom command. We run the SD sidekick command with the subcommand create command and pass it a name of the command we want to create. Create command, that's actually a pretty funny name to pronounce. Okay, now we can directly run our brand new foo command, so sd-foo, and okay, now you just see a success message because we haven't actually implemented any of our command code yet. But let's see at what happened when we generated this command and how did it get added to our CLI. So two things happened. First thing, the command was registered in the CLI runner. So the sd_sidekick.dart file here, and just 2 lines. An import was added of our command, and we added the command in the runner. Now let's take a look at the foo command that was generated in our directory in the commands folder. This is it. You can modify it, you can change the description, which will be printed in your CLI when you use it. You can change the name. And here in the constructor, you can use the arg parser property to add options and flags and so on. And then finally, there's the run method, which we will edit to implement the logic. So our foo command up until now is pretty boring, and I want to edit it so it does this, the following. Don't read the slides yet, listen to me. You can get as creative as you want with your commands, so there's no limits. You can do everything you can do in Dart. For example, you could write a command which deploys your whole app to AWS, or a command which makes an API request to get open issues from Jira for your daily stand-up. So anything's possible. But for now, let's stick with this simple example. So I want the foo command to return the length of all Dart files in a given path. And it should take a named mode parameter here. And with this, you can switch whether it should count the lines or the characters of all Dart files. Let's look at, I also want that the example invocation here is customized. And so a bit of explanation about this. Square brackets mean optional parameter, or optional, and angled brackets mean required. So I want to be able to override the mode parameter, but I want it to have a default value, which is lines. All right, let's implement this in our foo command. So I can just copy and paste the description up here and the invocation as well. And to add the parameter, the option, I can call argparser.addOption. I can give it a name, a shorthand abbreviation, help, allowed values, and a default value. That's pretty easy. Let's look at the implementation, the run method. So a lot of things are happening here. Let's start at the top, here. So what's happening here is that I'm getting the parameters through the arg results property of the command. I can access named parameters like the mode with the square brackets, and I'm casting it directly to a non-nullable string, and I can do that safely because I have a default value here. Otherwise, it could be nullable as well, because your users can type in whatever they want. So. And the next thing I'm getting is the path parameter. And this is a positional optional argument. You see here in the invocation, it's a positional argument because there's no name in front of it, and it's optional because it's in, I want it to be optional, so that's why I put it in square brackets. And to get positional parameters, I can use argResults.rest, and I get the first one, but because it's optional, I have to write first or not. All right. Next step is to get all the relevant Dart files for our command. So remember, we want to count all the lines or all the characters in all Dart files in this path. So we have to get all the Dart files first. to do this, I want to get the directory in which I want to start the search in. And if a path was given, just use it. Otherwise, I have to have a default or fallback value. And for this, I can use Sidekick context, which the Sidekick core package offers. And this is the location in which the entry point file is placed in. So the SD file you call to execute your CLI, which in our case is just at the root of the repository. Great. Now I can recursively get all files, and I want only files ending in .dart. Okay, the next step is to do a little check. So I want to treat it as an error if no files are found in the given path. In that case, I want to print a big red warning to the user, so you know something is wrong. And very important, I also want to set an exit code. This will be important later on for things like command chaining, and yeah, to make sure that your CLI is well behaved. Okay, then final step, everything is ready, everything is checked, we are in the happy path, and now we can use a pretty cool new .3 syntax, pattern matching. And so remember, mode can only be one of two things. It can be either lines or characters. That's because I used the allowed parameter when I added it. So the arg parser makes sure, okay, is it one of these two values? If not, it's not even going to execute my run method because it's going to print a warning way earlier. So I write a switch, a pattern matching for these two values. And this case here, the default value is just to make the compiler happy because it doesn't know about this. So in the lines case, I get all the files, I read their lines and count their numbers, sum it up. And in the characters case, I read them as strings so I can get the length of the file in string and sum it up as well. And in the end, I just print it. Whew, everything is done. Perfect. Let's run our new command, and you can see it works fine. There's 3 Dart files in our Dart CLI package with 94 lines. I can switch the mode, and then I see there's like 2,000 characters in our Dart CLI package. And the error case also works. Let's, so who sees this for the first time? The double pipe operator in a bash. Oh wow, you're also smart. Okay, I'll still explain it. So you can use this. It basically says, please only execute the following command if the previous command failed. So this echo will only be executed if this command here fails, which it does. And then the other magic is this $?, which is just the exit code of the previous command. So it prints exit code was 13, because we set it to 13. Awesome. Another cool thing that Sidekick or having a Dart CLI enables us to do is testing commands. And we should always do that because we're being good developers. So this is really easy with Sidekick. Let's say I want to write a test which checks that the right message is printed, that it's formatted in the right way. I'm just defining a regex here, which matches the message. A number of Dart files with a number of lines in path should be printed. And then I want to call my command. And for this, I can again use this pretty cool Sidekick context helper here. I get the entry point, which is the executable SD file, and I execute the foo command with lib as positional path parameter, and then I just start it, and I also pass this progress variable. I can use this to capture the output of a command. So I can afterwards, after it has run, I can check the output, so std out, std error, and the exit code. And here I'm checking it. I'm checking the last line. It should match my regex. That's it. that's so easy to test. So it's very easy to test your own commands. I would have no idea how to do this with Bash. Let's now take a look at how to debug CLI commands. And because we're good developers, we're going to debug with breakpoints, not print debugging. That doesn't count. So first of all, of course, you set your breakpoints in the IDE, and then you have to somehow start your CLI and get it to hit the command code. And there's two methods to do this. You can either add a run configuration, and this is for IntelliJ. You can also do it in VS Code with the launch.json. And there's two things you want to set here. So for the Dart file you want to execute, you just set it to the bin/main.dart file in your CLI package. And here at program arguments, you pass it the parameters. So the first parameter is, of course, the command. We want to debug the foo command. And afterwards, I can pass it any parameters I want. A cool thing is that I can also change the working directory, so if my command were to behave differently depending on the directory I'm in, I could also change this here. Yeah, so, and now you can run your, you can run this configuration and it will hit the breakpoints in the command code. Another method I like to use for debugging is adding a test and calling your CLI's run method. So in my case, the CLI is called SD, so the run method is called runsd. And I can also pass the command name here and all the other parameters here in the list. And this way, it will also hit your breakpoints in the code. If you remember earlier, in the other test, we didn't use the run method, but we used basically a string, the command we want to execute, and then .start on it. But if you were to use this, you wouldn't hit the breakpoints. And that's because start actually spawns a new process, so you won't hit the breakpoints in there. Yeah, but this works. And yeah, you can see that now I hit the breakpoints, which is super nice for debugging your commands if you want to look what's going on, and makes it very easy to develop new commands. Okay, I've said it sometimes, that as developers we love to be lazy. I mean, that's why I named my CLI just SD, just 2 letters. I don't want to move my fingers too much. And a powerful feature of Sidekick CLIs is that you can use plugins to easily add new functionality. So let's take a look at some. So you can install plugins for Sidekick from a lot of sources, from local paths, from Git repositories, from pub.dev or other pub servers. And to do this, you can use the SD and then Sidekick plugins install subcommand. Say which source you want to install from. By default, it's from pub.dev, and then give it a package name, local path, or Git repository. You can also pass a specific version if you want to. And what happens when you run this command is that so each plugin has a install.dart script, which will be then called by the plugins install command, and this install script modifies your Sidekick package. And it can do anything the plugin developer wants it to do, so it can modify your CLI, it can add new commands, it can register new commands, it can modify existing code in your CLI, add imports, anything's possible. So let's take a look at an example plugin. Let's install Sidekick Vault to our CLI. This is a very cool package which enables you to add secrets, so like API credentials, to your Git repository safely, because if the file is encrypted, you can just upload it, add it to your Git repository, and you don't have to remember all the API credentials. And yeah, there's many other different ways to do it, but this is a nice way because it also enables you to reuse the API credentials in your commands. So I'm running the plugins install Sidekick vault command. And so at this point, the install.dart of the plugin starts, and it asks me for one directory, which is where I want to create the vault directory. The encrypted files will be saved in this directory later. Then the installer goes on to add the plugin as a dependency to our CLI package. So remember, there's two packages in play now. There's the plugin package, and we're executing its installer, and this installer adds itself as a dependency to our CLI package. The next thing that happens is that it generates a file in our CLI package, and this vault.dart contains a variable you can use to then load to encrypt and decrypt secrets in your repository. It also registers a vault command in your CLI. This is also pretty interesting because the vault command lives in the plugin package, so we import it. It's not copied into our CLI, but it's imported through the other plugin package. But so the plugin developer can decide. He could also copy the plugin command into our CLI package. It depends on what you want to do. There's lots of possibilities. And the last thing that happens here is it creates the vault. And the vault is just a directory which has a git ignore that's set up to only commit GPG encrypted files to the repository, so you can sleep safely and without worries that you'll accidentally commit unencrypted files to your repository. And it also contains a README on how to use the vault. Awesome. Now I can add my deepest secret as an encrypted file to my Git project, to my Git repository. I do this with the vault encrypt command, and then I pass it the file I want to encrypt, as well as a password I want to encrypt it with. Then this encrypted file will be saved to the vault directory I selected earlier, and you can see here it's saved as a GPG encrypted file, so you can just commit it. There's no safety harm in that. And then I can decrypt it afterwards with the SD vault decrypt command. And I will have to, again, enter the password I used to encrypt it. Great. But until now, we only saw how to decrypt secrets on the CLI, so with the decrypt command. But let's say you're writing a deploy command, and in the deploy command, you're going to need to decode some secrets. For example, you're saving the API credentials in the vault. So you're going to need to decrypt the secrets in the deploy command because, well, you need them to call the endpoints or the commands to deploy your app. So let's take a look at how to do it in code. So I've written tests here. It doesn't make much sense to test this. In my opinion, it's just for demonstration purposes. So these tests all pass. Let's start with the error case first. If I go on to call vault.loadText and then my secret file, it will throw an error because I haven't provided a password. So remember, if I run the CLI version, which is vault decrypt, it would ask me for a password. But because I'm running it in code, it can't really, it isn't interactive, so you have to pass it in another way. And there's two methods to do this. The first method for passing the password is to add an environment variable. It must be called, in my case, SD_vault_passphrase, because my CLI is called SD. And then I pass it the password here. If I now call vault.loadText, it will be decrypted, and you can read my darkest and deepest secret, which is that I like pineapple on pizza. And you can't tell anyone because they will take my Italian passport away. So please don't. The other way is that you can use the vault.unlock method to decrypt the vault. Yeah. So let's say you're still writing the deploy command and you're done writing it. Now let's see how you can use the deploy command of your custom CLI on CI. For example, if you're using GitHub Actions, you will have a YAML file in which you have defined the steps that should run. And the cool thing about Sidekick CLI is that you don't have to worry about bash anymore. You can just call your CLI. So in my case, it would be called SD. Now it's just a more general, this is just a demo, I just called it your CLI. Depends on your project what it's called. And this does everything for you. So first, I initialize the CLI by just calling it. And this will cause it to compile, because this is running on CI, so you're running on a fresh machine. It hasn't compiled your CLI yet, so just call it first. Then get the dependencies for all the packages, and build your app. And now you want to deploy your app in this step, and you just run the deploy command. And so the deploy command can access the credentials and the secrets in the vault. I pass the passphrase as an environment variable here. And you can store the passphrase in GitHub secrets, for example. Awesome. Let's take a look at some other Sidekick plugins. So there's some of them. There's FlutterW Sidekick plugin. This is a really cool thing because it enables you to pin the Flutter SDK per project. So what's the problem here? Especially beginners just have one Flutter SDK installed on their machine. And okay, what happens now if they're working with somebody and they upgrade their Flutter version? Maybe something breaks. And the idea here is that the Flutter SDK update should happen per project and not per developer. And what this Sidekick plugin does, it downloads a FlutterW script, which makes it much more easier to do this. It's just a wraparound around Flutter. It adds the Flutter SDK as a Git submodule, and this way you can make sure that every developer on your project is using the same Flutter version, and that the update happens per project. Sidekick Vault, we've just seen that. Then there's this bump version Sidekick plugin. If you install this to your CLI, you will get a new command which you can use to quickly bump the version of a package. So bump the minor, major, or patch version. And finally, there's the Dockerized Sidekick plugin. It's also a really cool package written by Justin sitting here in the front. It adds a Docker command to your CLI, and this makes it very easy if you want to deploy your app as a Docker container. Yeah, it just makes life so much easier, automates a lot of things. Cool. Sharing is caring. So let's see how you can write your own plugin and share them with the community or with your team. You can also write private plugins if you want to, but sharing is caring. So the Sidekick CLI has the plugins create command. There's some templates you can choose from. Don't worry about them now. And so now it generates a new Dart package for the plugin. And I can already install this plugin to my SD CLI from the local path. I can immediately call the command of the new plugin I just installed, which is baz, and it prints something. The plugin that we generated is a very simple Dart package. So this is the command that we called. And yeah, you can add more commands to your plugin. This is just a starting point for developing your plugin. Again, there's no limit to your imagination. And the other important file you'll have to worry about is this install.dart file, which again is used during the install process to add the commands to your own CLI. There's one thing you have to know, which is if you're developing a plugin And for developing it, you want to test it on a local CLI you have, so you add the plugin as a local path dependency. Now let's say you added the code in the plugin, and you're wondering, why isn't the plugin command updating in my CLI in which I have installed this local plugin? And that's because of the compilation stuff I talked about earlier. So the entry point script will look through your .cli packages code and see if there's any changes. So it calculates a hash to do this. However, it can't know if anything changed on a local path dependency, because it only looks at these files or directories to calculate the hash. So because your CLI is running in compiled mode, you will have to recompile it. And that's super easy. It's just one command. So sdcli, I call the Sidekick command with the recompile subcommand, and then it's compiling my CLI again, and everything works. You get all the updates from the changes you did on your local plugin. But remember, this is only necessary for local plugins. If you install a plugin from pub or git, you won't ever need this command. Yeah, what else is there to do before sharing a plugin with the community? You can add the topics parameter to your plugin's pub spec. This is new with .3, I think. And this way you can tag it. This makes it way easier to search on pub for specific packages. Also naming it as, for example, bar_sidekick_plugin would also make it easier to find. Then you can write some tests and documentation. You can look at the already published plugins for inspiration for that. And all there's left to do is run .publish and publish it to pubdev. And it would be really great to hear what ideas you have on which workflows you want to automate with your own Sidekick CLI. I'm happy to help if you have any questions, and I'm very excited to see which ideas you come up with.